adrenal gland. That's located on top of the kidney. And it's a gland consisting of an outer thick cortex with 3 different areas. And then deep inside is the medulla. And the medulla is a different function and is a different developmental origin as well. The medulla is where we secrete the adrenaline. So we know that's when you get the jitters after you have some scary event happening, for example. That's what the adrenal medulla does. We'll get to that in a minute. But the adrenal cortex has 3 zones. It has a zona glomerulosa, and that secretes aldosterone. And aldosterone influences water balance through sodium reabsorption in the kidneys. Remember, water follows salt. Salt's a water puller. And so if the system secretes sodium back into the body, that is, thought to be peed out, what happens is the water will follow that sodium and will retain more water in the system. So that's what aldosterone does for us. So it works similar to the antidiuretic hormone, except the antidiuretic hormone works on the water molecules themselves, and the aldosterone works on the salt molecules and the water follows. Then we have the zona fasciculata, and that secretes cortisol, which is a long-term physical stress hormone, assuring that the cells have enough glucose for energy, or also we can have it help make gluconeogenesis. That means we make more glucose from multiple different substances, from other macromolecules. The cortisol also reduces inflammation, but it also decreases blood levels of white blood cells, and therefore it inhibits the immune function to some level. The cortisol is we often get cortisone injections to reduce inflammation and reduce the pain in an area of a body, and that's a synthetic form of cortisone. So there's one reason why we don't want to have too much cortisone injections, is that it inhibits the immune system, and it decreases and it works also with the glucose level. So we want to be a little careful about that. The other thing that too much cortisone does is it decreases the calcium in that area of the part of the body we injected, and so that can give us localized osteoporosis or a diminishing of bone strength. The zona reticularis is then the deepest one, and it mostly secretes male hormones known as androgens, but it does that in both sexes, and it stimulates also that stimulates the protein metabolism and the muscle buildup. So that has to do with anabolism, muscle buildup, versus catabolism, which is the breakdown. Remember, anabolism is building up something, catabolism is breaking down something. Then the adrenal medulla, as we said earlier, is closely related and connected to the fight or flight part of the nervous system, the autonomic nervous system. So that means you're on the freeway, you get cut off by some whatever, and you swerve out of the way, you get a shock attack, and a little later you get the jitters. Well, that's where you get the jitters from the adrenal medulla. It secretes epinephrine, adrenaline, that is released during immediate stress, preparing the body for increased energy. So if you have stress, look at that thing on the bottom, that's a pretty good list. We have a short-term stress response, that's the adrenaline, and then we have a long-term stress response, and that's the cortisol. Next, we see the pancreas. And the pancreas is interesting because it has multiple functions. It had an endocrine function, but it also has an exocrine function. So the pancreas, one of the things it does, and we'll talk about that when we get to the digestive system, it squirts gastric juices, it squirts enzyme juice into the duodenum, the first part of the small intestine after the stomach, and that helps digest, meaning chemically break down a lot of the molecules, and that prepares the molecules then to be absorbed into the body. And so the pancreas does many things. That's one thing it does, is that gastric juice secretion. But it also secretes endocrine hormones that have to do with the glucose metabolism. It regulates carbohydrate metabolism. So we have two of them. We have insulin, and you probably know the insulin. That's promoting cellular glucose uptake and storage in the form of glycogen and fat. So we eat sugar, the blood sugar level goes up, the insulin gets secreted, the glucose goes into cells, meaning the insulin actually goes onto the cells and opens some doors or channels that the glucose can go in. And inside the cells, the glucose will be used for energy, but also it can be stored in there as glycogen, especially in the liver and in the muscle tissue, or it can become fat, and that's then stored energy. Glycogen, on the other hand, mobilizes energy reserves during starvation or in a stressful situation by breaking glucose reserves down. And we call that glycogenolysis. So glycogen reserves are glucose molecules, one after the other, like in beads. And when we chop those up and put each sugar molecule into the bloodstream, we enhance the sugar in the bloodstream, and that process is known as gluconeogenesis. So if we don't eat the sugar, the body will provide it. And the sugar is what gives us the energy to run around in the world. So glycogenolysis is in the liver, mostly because the liver is where we have most of the glycogen stored that is used for body, not for muscle. Muscle has its own. And so that's where that process happens mostly. The other thing that glucagon does, it helps us form glucose from other molecules, and that is known as gluconeogenesis. We make glucose from fat and from protein that way. So the pancreas has two hormones, insulin and glucagon, and they work antagonistically. One raises the blood sugar level, one lowers the blood sugar level. Insulin lowers the blood sugar level. And then we get to the gonads. And the gonadal hormones serve the development of the male and the female sexual characteristics and the growth of them, as well as physical and emotional maturity and reproduction, which is the generation of the germ cells. That's ongoingly. And then, of course, it has to do with the pregnancy, and then later in the woman, when the baby needs to be nurtured on the outside world, it has also a lot to do with lactation. You can see here all the effects of estrogen on the brain, on the breast, on the ovary, the bone, heart, liver, etc., uterus, vagina. That's the estrogen effects. And on the bottom left, you see all the testosterone effects. And those are just lists that I like you to keep so you can look this stuff up once in a while. All right, there's our endocrine system. Thank you for your attention.